Hi, so my name is Angeles and I am going to be presenting on the physics of cooking. So this is my PowerPoint presentation. I wanted to start talking about thermal equilibrium. So the scientific definition per se is the state in which two objects connected by a permeable barrier don't have any heat transfer between them. So an example that I'm going to use, just kind of an everyday thing, is boiling water. So I just came over to the fridge. So this was boiling. I don't know if you saw it bubbling in that way, but you can kind of see a little bit of the smoke coming off. And basically what thermal equilibrium says, if I were to place this in the fridge, over time it would have to reach the same temperature as the fridge. And if I were to put it in the freezer, which is in the bottom, over time it would end up freezing because thermal equilibrium sees for basically anything that had to reach the same temperature all at the same time. So I'm gonna talk about three different heat transfers, and the first one, which is the most common type of heat transfer, is called conduction. And it's basically just the heat going straight into the food. I've included a picture of a grill, so you can kind of see the grill marks right here, and that basically shows that the heat is going right onto the bars, which is going right onto the food, so that counts as a direct transfer. And then we move on to convection. So this is when energy is carried to the food through a fluid. And a fluid includes oil, water, and air. And I've included a picture of an air fryer. And the reason that I've done this is because you can see a little bit of food in there. So basically what an air fryer does is pressures in all the air to make sure that it's all compressed and the energy is transferred through that air onto the food. So it cooks at a way faster speed. So this is another common thing. It also exists in convection ovens, but I decided to use air. And then finally, it's radiation. So this is kind of most commonly used amongst college students. I would say like most of my friends use radiation because of microwaves, obviously. So this is basically when waves absorbed into the food and make the food heat up because of the friction that's creating. So I included a picture here that has a little bit of the red, I don't know if you can see it, but the little bit of the red waves and everything. And then the equation, if you would to want to see what the speed of light is at what it's heating up, would be 2 times, which would be the distance between the melted spots times the frequency of the microwave. So every microwave has a frequency. You would just need to check which frequency it would end up being. And then finally is my conclusion. So the three main things that I talked about was the three different types of heat transfers that happen when it comes to cooking and physics, which is conduction, convection, and radiation. And also I wanted to introduce the topic of thermal equilibrium because it is basically part of everyday life when it comes to cooking and physics. And in my paper, I will go into more depth talking about these concepts and exploring how each of them work.